I'm Anil Kumar. Welcome to my series on inequalities. Now, let us discuss some inequalities where quadratic functions are involved. We'll try to solve these 5 questions. The question here is, solve the following inequalities and graph the solution set. X square greater than equal to x, x square minus 4x greater than equal to 0, x square plus 7x less than minus 12, 36 minus 16x minus x square greater than 0, and x square minus x plus 1 less than 0. You can always pause the video, answer the question, and then look into my suggestions. Now, to solve inequalities, we could adopt 2 approaches. We could have a graphical solution, so we could graph and then find a solution, or we could have algebraic solution. That is your choice. Now, let me take the very first one, which is x square greater than equal to x, and show it both ways. So, we'll solve the inequality x square greater than equal to x. So, I'll sketch a rough graph to represent both, and then we'll try to understand the situation. Okay. Let us say that the graph of the function x square is like this. All right, so let's say that's the graph of x square. It's a parabola, it opens up, easy to make. So that's not an issue. And now let's also sketch the line y equals to x. So if I sketch the line y equals to x, what I get is kind of like this. So what we have here are these 2 graphs. One is y equals to x, a straight line which bisects the quadrant 1 and 3, and the other one is y equals to x square. Now, clearly, what you see here is that there are 2 points of intersection. Now, when I want the parabola to be greater than x, that means we are interested in everything but for this region where parabola is under the straight line, correct? So, basically, what we need is that we want to include the points when they are equal, so we'll include these 2 points. And the solution should be away from these 2 points. Now, if I move away from these 2 points, the graph of parabola is over the graph of straight line, and so we get our solution. Perfect. And this solution could be represented in a form of a graph, which we normally say number line. So we'll actually represent the solution on a number line. So I could say that if this is my number line with 0 here, in that case the solution set is away from 1 to the right side and left of 0, including both these points, correct? So I could represent the solution as left of 0 and the right side of 1. So that becomes the solution of the inequality x square greater than equal to x on a number line, right? So this point is 1. So that is what it is. At times, you may also represent the solution with interval. So we could say in interval notation, it could be written as minus infinity to 0, where 0 is included, or we could say union, and then from 1 to infinity, and then from, let me write here, okay, and then from 1 to infinity. Infinity is never included. Perfect. So that makes sense. So that is how it could be done. Now, let us also see how to find algebraic solution. To find algebraic solution, we bring them together on one side. So I could write this as x squared minus x is greater than equal to 0. So to find algebraic solution, bring them to one side. Now we could factor. So if I factor, I get x minus 1 is greater than equal to 0. Now, basically, we could again sketch and then see the portion which is below the x-axis and get our solution, correct? So let me show you this solution on the right, a small sketch. We have two zeros, one at 0, the other one at 1, so it's kind of like this, right? Greater than equal to 0 means the portion where the graph is above x-axis. So we get the same solution, right? The third method, which is more of algebraic way of doing it, is to have a table where we could find the intervals where the graph is greater than 0. Now these two are the zeros. That means at x equals to 0, the value is 0, and x equals to 1 also we have a 0, right? These are the two zeros. These zeros divide our interval into three regions. Now this one is from minus infinity to 0. Here we have from 0 to 1 and then from 1 to infinity. So these are the three intervals. What we need to do is to test where is this function positive. That's all, right? So we take test points. So let me define test points. In these regions, it could be minus 1. Here we could take 0.5 or half and 2. Now this particular function, x times x minus 1, let's test it out. As far as x is concerned, it is going to be negative for minus 1, positive for these two. And as far as x minus 1 is concerned, x minus 1 will be negative here, 0.5 will be negative, only for 2 it is going to be positive. Now, when you multiply two negatives, you get a positive. But when you multiply positive and negative, you get negative. Here, you get positive, right? So the intervals where this function is greater than or equal to 0 are these two intervals. So they become the part of solution, right? So the solution here is these two intervals as mentioned here. Does it make sense to you? So what we have done is shown you different ways of solving the quadratic inequalities. Now, we are going to use a hybrid approach. That is, we'll factor and then plot the graph and write down the answers. That's going to be very fast. See how it can be done in no time. So now let's move on and solve these questions in the most effective way. So the second one which we'll do is x squared minus 4x greater than or equal to 0. So we'll adopt algebraic plus graphical approach. So we'll factor x. So let me rewrite. We have x squared minus 4x greater than or equal to 0. If I factor, I get x minus 4 is greater than or equal to 0. Now I can always sketch it, correct? To sketch, we know we have two zeros in this case. One is at 0, the other one is at 4. Parabola opens upwards, right? So since the leading coefficient is positive, kind of like this. We want the values where the function is positive, greater than or equal to 0. We want to include this also, right? So the graph is above x-axis in the interval after this, including these points since these are the zeros. Do you see that? So that becomes the part of solution for the given function or inequality, right? So we know that zeros are at x equals to 0 and x equals to 4. So that gives you a parabola which opens up as shown here, right? So the region where the parabola is above x-axis, so the graph above x-axis is the solution. I hope that makes sense, right? So these points are 0 and 4. So what we see here is that our answer is that x is less than or equal to 0, or x is greater than or equal to 4. On a graph, we can show it like this. Let's say we have a number line, so we'll draw a number line. On a number line, we have a solution including 0 towards the left side and from 4 towards the right side. Does it make sense to you, right? So from 0 to 4, these values are not valid, but all others are valid. So that is shown on graph. Solution on graph. So I hope that is absolutely clear. Perfect. So we are going to follow this approach to solve rest of our questions. I hope you appreciate that this is indeed a very efficient way of solving inequalities involving quadratic functions. So let's take more examples. Now the question is to solve x squared plus 4x less than minus 12. We'll bring 12 to the left side. So I could write this as x squared plus 7x plus 12 is less than 0. This is 12. Now let's factor this. Product of two numbers being 12, sum 7. So we could factor it like x plus 4 times x plus 3 less than 0. That gives you two zeros, right? So why have zeros at x equals to minus 4 and x equals to minus 3? It opens up, right? So let us sketch this graph here and write down our solution. So the two x-intercepts are on the left side of y-axis as shown here. And these are the points. Now, the inequality is less than 0, so the 0 will not be included. So these two zeros will not be included in the solution set. Less than means the portion which is below x-axis, so everything in between. Does it make sense? So this is minus 4, that is minus 3. So the answer here is, in interval notation, I'll write this as minus 4 to minus 3. In a graph, which is normally number line, so we could use both these terms. The solution will be, this is my number line, then the solution is between minus 4 and minus 3 as shown here. Perfect. So that is how you're going to solve it. Now let's take another one. You can actually pause the video now, solve this question, and then look into my suggestions. Now in this question, what you notice is that x squared is with negative coefficient. So what I prefer is to move it in a way so that we get this as positive. Correct? So we'll take all these terms to the right side and we can write that 0 is greater than x squared plus 16x minus 36. So I hope that makes sense. So we took all these terms to the right side, leaving 0 here. 0 is greater than this, right? Or you could say x squared plus 16x minus 36 is less than 0. One and the same thing. Now when the inequality is less than or greater than, then zeros are not part of solution, right? Now let's try to factor this. So 36 18 times 2 is 36. So we could factor this as x plus 18 times x minus 2 is less than 0. Let's try to sketch it. Now it has two zeros. One is at minus 18 and the other one is at plus 2. So we could graph a function kind of like this, right? So these are approximate graphs which gives you an idea. So this is minus 18 and here we have 2. These are the two zeros for the graph. We want everything which is less than. That is to say, the solution is within this portion, correct? So it is from here to there, not including these points. Does it make sense? So on a number line, I will show my solution as what? Let me write here. When we say graph, we mean the number line. It is between minus 18, not including it, to 2. Sometimes you may be required to write an interval notation. In that case, you will say x belongs to, you can say, between, not including, so minus 18 to 2, not including. So these are different ways of answering this particular question, right? Now here is the last question, which says, solve this equation, x squared minus x plus 1 less than 0. You can now pause the video, answer this question, and then look into my suggestions. Now I cannot really factor this since 1 is 1 times 1, and when I add and subtract, I don't get 1, right? So we'll use quadratic formula. So if the equation is ax squared plus bx plus c equals to 0, in that case x is minus b plus minus square root of b squared minus 4ac divided by 2a, correct? So we are going to apply this particular formula to find x-intercepts, right? So to find x-intercepts, I'll use this formula. So what I can say is that x is equal to minus b, which makes it positive, plus minus square root of 1 square minus 4 times ac, which is 1 times 1, over 2 times a, which is 2. So that gives you 1 plus minus square root of minus 3 divided by 2. Now this is imaginary, right? Not real. So we do not really have an x-intercept in this particular case. So we can see that the y-intercept is at y equals to 1. If I write x equals to 0, that means f of 0 is what? If I write 0 here, I get 0 minus 0 plus 1, which is 1, correct? So y-intercept is 1. Also, parabola opens up. And clearly, since we do not have any x-intercept, if I have to sketch it, how is it going to look like? So we are not getting into details of sketching, but we know it should look like something like this, right? Where definitely the y-intercept is 1. So this point is 1. And there are no x-intercepts. We want this graph to be less than 0. So we find that it is never less than 0. And therefore, our answer is null set or no solution. So you could have inequalities which may not have any solutions, right? So I hope you understand that inequalities may have infinite solutions or even no solutions. So whole range is possible. So in this particular video, we learn the most effective way of finding a solution is a combination of graphical and algebraic approach. We could actually purely solve these equations using graph or also algebra, but this hybrid approach is very effective to get quick solution to our quadratic inequalities. I hope you understand and appreciate it. Feel free to write your comments and share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.